Hey guys, it's Mr. Wolfe here, and I'm going to be going over constructing graphs. And so before watching this video, make sure you guys watch the flipped video on constructing data tables. And so kind of following up with this one, so we have our data table. Now we need to make sense of that data. All right. And so this goes into why we construct graphs. And so we construct graphs to create a picture of the data. When we do this, we're able to determine trends. Essentially, we're able to see what is the story of the data. And when we see these trends, we're able to compare control group to the experimental group. So these graphs allow us to analyze our data and draw conclusions. So like last video, we're going to have a checklist and we're going to be going over some examples, but also when you guys are going to be constructing graphs throughout the year, sometimes they may not always follow the rules that we see here with these examples I show you. So just like with the data tables, always keep a certain mindset when constructing your graphs in terms of, what do you want your graph to say? And you should be thinking, how can my graph best tell the data's story? Right, the reason we're making a graph is to make sense of this data, and we want to be able to do that in the best way possible. So we have a checklist of a couple things to keep in mind of. The first thing we want to do when constructing a graph is to label our axes with units. All right? And so in general, most of the time, if we have a graph, we want our independent variable on our x-axis, and we want our dependent variable on our y-axis. And a way that I could sometimes think about it is if we have a graph like this, you can't make a d out of the x-axis, but you can make an I and then a d here. Just a helpful way to remember that. All right, so let's label our axes. And in this case, we have our data set right here. It's pretty simple data. Just in turn, what they were doing is measuring the amount of mice caught per night over a certain amount of time. And so they were measuring the amount of mice per night. That's our dependent variable. So we could label our y-axis number of mice caught per night. All right. And the units for this is essentially just the number of mice. Now they were measuring this over time, and so that is our x-axis. Almost always you will have time on your x-axis whenever we're graphing something. So time is our x-axis, and we want to include the units of time, not seconds, not hours, but days. All right, the next thing we want to do is develop a scale. And when I say that, we want to be able to look at our data, and especially if we're drawing our graph out, make sure that it essentially takes up almost all the space given us to draw a graph. So what I'm going to do for setting the numbers here is look for the highest number in my dependent variable, which is 45. So I want to make sure that 45 is pretty close to the top around here. And so what I'm going to do is I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 rows here. I want to find some number that's divisible by 8 that's close to 45. So 8 times 5 is 40, so that's not going to work because 45 would be up here. But if we do 8 times 6, that's 48. That would fit 45 right about here. So we're using a good chunk of this graph. So then we'll just go down by 6s. 42, 6. And for the x-axis, it's going to be a little bit easier because I realize that we're going up at equal intervals right here, and that there's 1, 2, 3, 4, 5, 6, 7, 8 points right here. Now there's actually 9 points on this graph here, but that's okay. We've used most of our graph at this point. So I'm going to put 0, 30, 90. So when we plot this graph, we're going to use most of the area that's given to us. All right, the next thing we want to do is just plot our data and make a key if necessary. So I'm sure you guys know how to plot your data by looking at a table, so I'm not even going to go in to doing that. And for this case, we don't need a key because we're only going to have really one line in this case in our graph. We don't need to differentiate at all. So the reason I'm going into these a little bit more in depth is because these are some of the points that I see my students missing when they construct their graphs. Speaking of that, the last thing you need, it's a simple one, but it's very important. Students forget it very often, is a title. Make sure that you do title your graph. And it should be something along the lines of the effect of the effect of our independent variable on our dependent variable. So just like our tables. So here would be the effect of time on mice caught per night. And just as a side rule, if we're working with time as our independent variable, we could also have our title say something along the lines of mice caught per night over time. That works as well when we're using time as our independent variable. So the last thing is, let's say you have data and you're setting up your graph, but you need to choose what type of graph you're going to use. And so the most common we're going to be using are bar graphs and line graphs. So when you use a bar graph, you're going to be using it when you are going to be comparing data from multiple categories. And this is when we're talking about our independent variable. And so for example, a category could be like males and females. Maybe we're measuring average height. All right, these are two distinct categories, so we will have a bar graph. All right, when to use a line graph? We're going to use a line graph when our independent variable is continuous data. And so when I mean continuous data, something like time, frequency, pH, something maybe even like volume. You know, this is essentially something that we could manipulate and move to different levels. And so let's say this graph is time, seconds, and our dependent variable is going to be velocity, meters per second. Notice that on these graphs, when I label my axes, I'm including my units. We might have something like this. Even if we only took a data point at, let's say, time 2 and time 5, we know that we could also have we could have measurements in between here, where for the bar graph, we really can't have anything continuous at this point here. So this is really it for constructing graphs. Remember, these are just some important points to remember when going about making your graphs. But remember, everything that's on the sheet is not always going to apply to a graph that you might be making. So if that happens, just remember, how can you make your graph to best tell the data story, to best make sense of the data?